All right, so I'm going to go over the unit circle, which is basically the foundation of being good at trig or just doing real trig. So it's, imperative. It's super important that if you want to survive trigonometry, that you know your unit circle, not just like memorize it per se, but, know what it is, understand it. And yeah, you're probably going to have to memorize it to some degree, but not memorizing in the sense where you like have no idea what the hell's going on. You want to memorize it like your multiplication tables. You understand them, but you memorize 1 times 1, 12 times 12, that sort of thing. Anyways, so here we go. So it all starts with this idea that we have a circle. As you can see, we call it the unit circle because we're saying that the radius is basically going to be 1 unit. Well, not basically, we're by definition, the radius is 1 unit. The radius equals 1 unit. Remember, the radius is the distance from the center of the circle, and we're going to have this be the origin, 0, 0, to the edge, or to the circumference. So let's look at this as a circle centered at the origin. So let's draw the x and y axes. Y or x. What's going on with my pen? But that'll do. It's almost dead. Okay, so now, since this is a radius of 1, we have 4 points at the, at these axes, axes intercept, at the intercepts, I guess, technically. And let's remember how we rotate or measure angles in geometry. We work our way counterclockwise. So we're going to be working our way starting from here. This will be our 0-degree mark. And we're going to rotate in this direction. Now, at 0 degrees, the coordinates are going to be 1, 0. Remember, x, y. Rotating 90 degrees up to here. So this will be 90 degrees. Our coordinates will then be 0, 0, 1. 0, 1. Let me put a box around it just so it stands out a little bit better. Keep on our trip all the way another 90 degrees to the horizontal axes on the left here. This will be 180 degrees. And this will have coordinates -1, 0. Keeping our journey going all the way to the bottom here. Will put us at 270 degrees, which will leave us at 0, -1. Whoops. And then if we kept on going, we would end up back at the beginning. So remember, when we rotate a full 360, we end up going or coinciding with our starting point. So we're going to be back at 1, 0. Okay, so 4 coordinates of the unit circle we have here. Now let's look at the other 3, 6, 9, 12 points and angles. So let's focus first on the ones in the middle here. And I'm going to recommend I recommend using 3 different colors, at least when you first learn this. You don't have to use any colors. If you're an adult or a kid, do whatever you want. Use one color, use a pencil or crayon, just do whatever you want to do. But I like colors and I recommend it if you really want the concepts to stick out to you, especially when you use a red and a green and a blue. So starting with the midpoints, so to speak, let's highlight them in red. And let's connect them. across with a straight edge to show the symmetry. Connecting vertically as well. Mm-hmm. And let me grab like a better thing to write on. This desk is like, oh, a physics book. Nice. All right, cool. Now let's label these. But let's first recognize what's going on here. So you see here we have a triangle. And let me actually use my very expensive protractor that I got at like a thrift store for like 25 cents, I believe. And let me draw a circle there because it's going to help us recognize what's going on. So starting at the terminal at the at the positive x-axis, going to here, rotating up to here is 45 degrees. It's a 45-degree angle. Now, at this point, the coordinates are going to be square root of 2 over 2, comma square root of 2 over 2. You're like, well, why are they the same? I'll tell you. Because what you have really here is a triangle with two congruent sides. So you have an isosceles triangle. Let me shade it in here. So this leg from here to here is the same as this leg. Remember, this is the height, or this is the width, or the x-axis, or the x coordinates. This is the height, or the y coordinates. And let's draw like a reference one over here so we can make it more clear. So these are going to generate these 40. Well, it's actually looking okay. So these are going to generate these isosceles triangles with the 45, 45, 90 degrees. And remember, this hypotenuse leg is 1. This is 1. And then that means this leg here, from here to here, is root 2 over 2. And then this is going to be the same, obviously, which is root 2 over 2. And you can prove this by just squaring these and adding them. So going over here, if you don't believe me, square root of 2 over 2 squared plus the square root of 2 over 2 squared equals 1 squared. We're just doing the Pythagorean theorem. 2 over 4 plus 2 over 4 equals 1. 1/2 plus 1/2 is 1, so we're good. So what you have are basically 45, 45, 90 triangles being generated. So we're rotating another 45 to 90. We already got that point. So let's go another 45 to here. And then this angle will be 135. The angle from here to here is 135. Because again, think of this as a isosceles triangle. Now, on this side, this is the left of the y-axis, so the x-coordinates are negative. And see, it lines up at this point. So then the y-coordinate is the same, root 2 over 2. And the x-coordinate is just negative root 2 over 2. You can think of it as just the reflection, or again, just remember it's just a right triangle, or with 45, 45, 90. Just like this whole thing, I mean, shading that in. And we keep on working our way around. Another 45, so 180, we got that. Let's go down another 45 to here. That'll put us at 225. And this will then have the same x coordinate, but opposite y coordinates because x and y are both negative over here. So negative root 2 over 2 for both x and y. Remember, these are just coordinates. And this is quadrant 3. I'm not sure if they teach you this yet, but let me just do it here. Quadrant 1 over here. Quadrant 2. Quadrant 3, then quadrant 4. And then finally, we finish off with going over here. Another 45 past the 270. We'll leave this at 315 degrees. The same x coordinate as above. So root 2 over 2. And the same y coordinate here. So negative root 2 over 2. All right, nice. Let me get some water. Math is making me thirsty. Okay, so now let's look at the next set of 4 points. Over here, let's choose blue. Or you can use whatever color you want, but I'm using blue. And from there, we're going to connect them. Man, what the heck? Yeah. All right. 45, 45, 90. I dare to use this thick marker because I want it to stand out. There we go, big time. Big time highlighting. Whoa, whoa, whoa. It's important stuff. Go big or go home. Okay, cool. So here we have our scope where we're going to zoom in this case. So look at these 4 points. Now what we have is not a 45, 45, 90 triangle, but we have, and let's go ahead and use my expensive protractor to draw this rotation. I want to screw it up. Nice. Starting from here, rotating to there. We're going to go 30 degrees. This angle is 30 degrees. We have our 90. That means this angle here is 60. And the coordinate here will be, for x, will be root 3 over 2. For y will be 1/2. So similar to the 45, 45, 90 triangle, we have a 30, 60, 90 triangle. So let me over here for a reference. Let's draw one. What we have going on. We have a 30-degree angle here, the 60 here. The hypotenuse is still a length of 1. This leg, or this leg, is root 3 over 2. And this height is 1/2. And you can prove this again with the Pythagorean theorem. I'm not going to do it because I don't want to run out of space. So trust me. Trust yourself. So let's keep on going. Let's go all the way to this guy, past the 90, past the 135. So you can think of this as 60 past the 90 or 30 before the 180. And that'll put us at 150. And the x-coordinate will be the opposite of this one, negative root 3 over 2, because it lines up with that. Y-coordinate is the same as 1/2. I bet you're catching on to this now. You're seeing the magic. Let's go below. Down here, we're gonna go 30 past the 180, so this is gonna be a 210. Y-coordinate will be negative 1/2 because we're below the x-axis. X-coordinate stays as negative root 3 over 2. Simple. And lastly, we go to this guy. 2, 3, 4. This will be 60 past the 270, putting us at 330. X-coordinate, the same as above, root 3 over 2. Y-coordinate's negative 1/2. All right. Now the grand finale. These 4 points. Let's use green. Why? Because green is the only really other color I have. Hopefully it lasts. And again, let's connect them. You know the drill now. Dun, dun, dun. Boom. Bang. Zoom. Poof. Okay, now. So what's going on here? Well, I'll tell you. This angle, oh yeah, the rotation. I'm going to go all the way out to let's go to the 40s. Don't want to screw up. Nice. Rotating up to here, starting here, rotating to here. This will be 60 degrees. Now, if this is 60, this is 30, and then this is a 90. So essentially, we kind of have the same triangle as this guy, but just standing up on the other side. And this coordinates, the coordinates of this point will be 1/2 for x and root 3 over 2 for y. And over here, let's draw a sketch of what's going on so you can get it. Conceptually, we just still have a 30, 60, 90 triangle. It's the same as this, but this is just this base is going to be the 1/2. And this is the root 3 over 2. This is still 1, of course. That means the angle 30 is over here, and the 60 is over here. You see that? So you can think of this as just the same type. Well, it is the same shape, same size, just a different location. So working our way around, we just keep on going. Let's keep the rotation back going. So going another 30 past this 90 or 60 more. This will put us at 120. X coordinates. That's right, negative 1/2. Y coordinates, root 3 over 2. All right, a little more, a couple more. 1, 2, 3. This point, going all the way. We have the 180, 60 past the 180, 240. Yep, that's right. The x coordinate is still negative 1/2. And the y coordinate is negative root 3 over 2. And for the final one, dun, 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 240 to the 270, another 33 hundo degrees. The coordinates of this will be 1/2 for x and negative root 3 over 2 for y. Whoa, whoa. Yeah. All right. There you go. The beauty of the unit circle really is a thing of beauty, like all math. But again, this is the foundation. Let me zoom out a little bit for trigonometry, and you'll see as we start getting into the graphs of the sine and cosine functions and looking at how we transform them and all. But again, make sure you understand this and memorize it by not memorizing, just understanding it, seeing the pattern of the 30, 60, 90, 40, these triangles coming up. And you're going to enjoy life, and trig is actually going to be probably the most enjoyable math you've learned so far because it's going to be very simple. So I hope that helps. If it does, let me know. Give me a little thumbs up, a like. Feedback is always welcome. Improvements, I'm open to that. Leave me comments, good, bad, any, whatever. And of course, subscribe if you haven't yet. And I will see you guys in the next video where I go into some more trigonometry of the graphing of the cosine of the trig functions. See you guys later.